Hi, this is Kenny Lee, and we're going to talk about angled projectile motion. Now, in all these examples, we're assuming that air resistance is negligible, which it means it simply doesn't matter. And so with that, a projectile is anything that's moving in two dimensions, I guess we can say in the air, and it has no means of keeping itself aloft or controlling its flight. So a plane, a helicopter, a rocket, those would not be projectiles. But a baseball, or if you threw a rock, or a bullet after it leaves the barrel of a gun, anything like that would be considered a projectile because it has no way of controlling its flight. So let's look at these examples down at the bottom. Just as a conceptual thing, if we ignore air resistance, then projectiles follow a certain pattern. Their flight path is always a parabola. Okay? And this one I've got marked as 30 degrees. Now the neat thing is if I shot that one at 30 degrees and it landed there, and I shot another projectile at the same velocity, but this time at an angle of 60 degrees, it would land at the same point. 45 degrees will give you the maximum range for a projectile. So any projectile shot at 45 degrees will go further because at 45 degrees there's an even split between its velocity out and its velocity up. The velocity up controls how long it stays in the air. The velocity out will govern how far it moves. And remember that these two motions are independent of each other. So horizontal motion does not affect vertical motion and vice versa. So equal angles from 45 degrees give you the same target. Or another way to do it is to do this. If I shot two projectiles, one of them at, let's say, 40 degrees, what other angle hits the same target? Well, you can just take 90 minus the angle that you're shooting at, 40. 50 degrees would also hit the same target. But 45 will give you the maximum range. Any angle further away from 45 degrees, the range gets closer and closer and closer and closer. At 90, you spend a lot of time in the air, but don't go very far. And 10-degree angle, which would hit the same spot, will be very quick, but still it won't go very far because it's not spending much time in the air. And we call that path that a projectile takes in the air a trajectory. And it always follows that parabolic path. So let's try an example. On this example, we've got this projectile fired at 25 degrees with a velocity of 60 meters per second, and we want to know its range and how long it will stay in the air, or its hang time. Range is simply how far it travels before it hits the ground. And on all these problems, we're shooting from level to level. So we're not hitting a target that's above the ground or below the ground. So we're not shooting at a target that's in a tree or something that's in a valley at an angle. We're shooting from level to level. And if we can do that, well then, it's kind of a paint by numbers type process. The first thing we need to do is get the components. We need to know how fast it's traveling horizontally and its original velocity in the vertical. So if we set that up like this so that our right angle is with the horizontal, then the velocity in the y would always use the sine function. And the velocity in the x will always use the cosine function. So let's place this in. So we got a velocity of 60, sine of 25 degrees. So we go to our calculator. That gives me a velocity of 25.36 meters per second for the velocity in the y. For the velocity in the x, same calculations, but this time we're using the cosine. And that is going to be 54.38 meters per second. After you get the components, we need to figure out the time and error. And this is one where I've got a special equation for you. As long as we're shooting from level to level, the time of flight will always be twice the vertical velocity divided by gravity. And I'm going to use 9.8 for gravity in this case. Sometimes people use 10, sometimes people use 9.81. I'm going to stick to 9 for all my examples. So twice the vertical velocity, which is 25.36 divided by 9.8. And 2 times 25.36 divided by 9.8 gives me 5.18 seconds. So it's going to spend 5.18 seconds in the air before it lands. And to figure out the range, well, there's nothing causing it to speed up or slow down in the X direction. In the Y direction, gravity's slowing it down. It'll go up and gravity eventually slows it down and brings it back down. But side to side, there's nothing affecting it. So for side to side, we're going to simply use velocity equals distance divided by time. My velocity in the X is 54.38. The range, we don't know, and the time is 5.18 seconds. So I'll just take 54.38 times 5.18, and I get a range of 281.6, call it 9 meters. Now sometimes people would prefer to, instead of writing it like this, to write this, dx equals vx times t. They're both the same thing, they're just one is solved for something else. What if we want to go the other way? Let's say we've got a problem like this one, that I don't know the angle or the velocity, but I do know the range and the time of flight. Okay, so how do we handle this one? It's basically backwards of what we just did. I know the horizontal distance and the time. So if I know the horizontal distance and the time, I can figure out the horizontal velocity. Because time, since it's a scalar, will be the same for both sides, both the vertical part and the horizontal part. And so for this one, we've got 200 meters and a time of 1.5 seconds. So that will give me a velocity of 133 1/3 meters per second. So I know that. Well, I need to know some other things too, but what I can do is, since I know that, I can also, using the time of flight equation that I just gave you on the previous page, figure out the y component of the velocity. So time was 1.5 seconds. We don't know Vy, but gravity is 9.8. Now if I solve that by multiplying both sides by 9.8 and then divided by 2, I get that we have a horizontal or vertical velocity of 7.35 meters per second. Now I got these two parts. Well, what that gives me is I've got the two legs of a right triangle. I've got the vertical part, 7.35 meters per second. I've got the horizontal part of 133.3 meters per second. I can use Pythagorean theorem and tangent to figure out the velocity and the angle. So let's figure out the velocity first. So this is going to be a squared plus b squared equals, well, v squared in this case. The vx and the vy. So 133.3 squared plus 7.35 squared. 133.3 squared plus 7.35 squared gives me 17822.91 and a little bit more. Then I want to take the square root. So that gives me my velocity of 133.5. So it's almost shot completely horizontally, it looks like. But let's figure out the angle to make sure. So for the angle, I'm going to use tangent. Tangent's opposite over adjacent. So tangent of theta, opposite side 7.35, adjacent 133.3. 7.35 divided by 133.3 gives me that. So I need to find the angle. So I'm going to use the inverse or arctangent of 0.05513. I want to keep a little bit extra because that's such a small angle. Actually, I want to leave it in the calculator and just take the inverse tangent of it. And I get theta to be 3.1, let's call it 6 degrees above the horizontal. Okay, thank you for watching the projectile lecture and problem solving. Tune in again for more physics. Goodbye.